Okay, so we're going to get some more practice with graphs now by playing a matching game. So if you have two charges that are on the x-axis, there are only so many choices that you have for graphs. So recognizing this can help making drawing the graphs easier. So we have 4 different choices here, and you have to match each of these charge distributions to the appropriate graph. In this column, we have the x component of the electric field plotted along the x-axis. In the next column, we have the x component plotted along the y-axis. And in the last column, we have the y component plotted along the y-axis. What's not shown here is the y component plotted along the x-axis, because for all 4 of these cases, that would be equal to 0 all the time. Okay, so notice that for 3 of the graphs that I have in the left column, they look very similar. So these 2 are the same, except that this point where the graph crosses 0 is shifted over. That looks similar to this, except this graph is flipped. That looks quite different than what we have here. Okay, now I'm going to look at my charges here, and if I have 2 negative charges, somewhere in between the field is going to be equal to 0, so that can't be this graph here. If I have 2 positive charges, right in between the field is going to be equal to 0, so that can't be this graph here. If I have a positive and they don't have the same magnitude, the field is going to be 0 somewhere in between, but not right at the origin. So that would be this one here. So it's 0 a little bit to the right. So this would be the plus 2q and the plus q. These are both positive, and so that looks like this one here, but just with the 0 shifted over. So this must be the plus q and the plus q, and let's make sure the field is pointing in the correct direction. If you are really close to the plus q charge here, the field would be pointing away, which is the positive direction, so it's positive here and positive here. And then when you're close to this charge on the left side, the field would be pointing this way, so it's negative there and negative there. So that works. So this one must be the negative charge and the negative charge, so that would be negative q and negative q, because it's 0 in between, and when we're really close to the negative charge, the field's pointing towards the negative charge, which is in the negative direction. Which means this one must be when the 2 charges have the opposite sign, so that would be plus 2q and minus q, because in between these 2 charges, the field is always pointing that way. So that would be this one here. Okay, now when we do the x component along the y-axis, when the 2 charges have the same magnitude, so it would be plus q and plus q. If you pick a point up here, that's pointing away, this one's pointing away, and the x components are going to cancel out. If they were negative charges instead, then, so if it was negative instead of positive, it'd be pointing like this, and the x components would still cancel out. So one of these is plus q, and the other one is minus q, minus q. So the question here is then, what I have left is the plus 2q and the plus q, and the plus 2q and the minus q. And the graph looks the same, except that one of them has a larger max. Now if we go back to problem 27, problem 28, we can see that for the x component along the y-axis, which is what we're looking at here, the graphs do look the same. And I did not draw them to scale, so I don't really know which one is greater, but I can go back to what I had here. So for the plus 2q and the minus q, these vectors, if we're looking at the x component, we're adding together to give you something larger in the x direction. For this one here, the vectors were pointing like this, so that the x component that you have here was being subtracted from what you have here, giving you something smaller. So we would get a larger value, or you could look right at the origin here. These are adding together. These are not adding together. So we should have the larger value when the signs are opposite. So that would be this one has a larger max than this one here. So that's the plus 2q and the minus q, because in between those vectors for the individual fields are pointing in the same direction. Okay, so this is plus 2q and minus q, and the other one would be the plus 2q and the plus q. Okay, and then finally we look at the y component along the y-axis. Now one of these is going to be easy because here this is positive, this is positive, this is positive, this is negative. So which one would be negative? That would be when we have a negative charge here and a negative charge here. So that would be negative q and negative q. So that's different than all the other ones. So this is the y component along the y-axis. And when we're up here, that's when y is positive, and the y component is pointing downward, so that gives us something negative there. So that's that one. And when we have plus q and plus q, we should have the same absolute value. So this graph here looks like it has the same value, but it's positive instead of negative. So that would be the plus q and the plus q. And then you have to figure out for the plus 2q and the plus q and the plus 2q and the minus q, which one's going to be larger and which one is going to be smaller. So let's go back again to the diagrams that we had here. So now we're looking at the y component along the y-axis. So if we look at the y components here are adding together. So when you add these two vectors together, the x component is going to be smaller than what it was for the red vector, but the y component is going to be larger. Here, when you add the two vectors together, the x component is going to be larger than what it was for just the red vector, but the y component is going to be smaller. Okay, so what were we doing here? We were looking at the y component along the y-axis, which is going to be larger when you have plus 2q and plus q. So this one's got to be plus 2q and plus q, and this one should be plus 2q and minus q, plus 2q and minus q. Okay, so you can take a look at the finished product here. So there's the top of the page, pause it if you need to, and there's the bottom of the page. And I guess what you could do to kind of finish what we're looking at here, what would you have for plus q and minus q? And that is similar to what we saw in the PowerPoint, and actually not that different from this situation here. So if you look at the graphs for the plus 2q and the minus q, so that's plus 2q and minus q, it would look similar to what we have here, but this would be shifted over here. Plus 2q and minus q here, that would have the same shape. And then if we look at the y component along the y-axis, if we have a plus q and a minus q, if we're up here, it's pointing away, this is pointing towards, and the y components are always going to cancel out, and you would have the maximum value for x here, so that gives us something like this for the x component along the y-axis, and the y component along the y-axis would always be equal to 0.